about the way we solve those problems and thinking about the steps that we took that allowed us to be able to successfully solve those problems. So this is grounded in research. There are two kind of really critical pieces of this. The first is you need the actual practice of solving the problem. But then in terms of retention, one of the most important pieces that research has shown us is that you need time to process and reflect on how you solve that problem if you want to transfer that learning from your short-term memory to your long-term memory. And so we're really excited to try this on Zoom. Normally we would be doing this in person, but I think Zoom actually affords us some unique opportunities to be able to collaborate and iterate together. And so I want to introduce you to a couple of features of Zoom that I think will help us as we're engaging in this practice. The first is that you can always use the chat. So if you look at the bottom of your screen, there is a thought bubble that says chat. So you can click that, and our goal is that you can ask questions at any time. So for me, I'm definitely going to try and figure out the right pacing so that we're moving not too quickly, not too slowly. But if you want me to stop and answer a question, using the chat is a great space to do that. At the same time, you can also ask a question by unmuting yourself. So you can actually hover if you go to the participants list. Just to the left of that, you see a microphone that has a mute button. So you can click to unmute yourself and ask a question. It's another way that you can engage and ask questions. So this is not intended to be something where I'm talking the whole time. Our goal is actually that we're going to work through and solve these problems together, and then we're going to have opportunities to be able to reflect on the most successful strategies that we use to solve these problems. So to give you just a brief overview, I'm going to share my screen with you. And there are two things that we're going to take a look at. The first thing is I want to give just a brief overview of the CBEST. So you have 4 hours total when you take the CBEST test. It has 3 sections, a reading, a writing, and a math section. You can choose to do all of those sections in the 3 hours, or you could choose to focus on a specific section. That's entirely up to you. And it is the sum of those 3 sections that determines a passing status for the CBEST test. There are 3 general categories that we're going to take a look at for math. We're going to look at computation and problem solving. We're going to look at estimation, measurement, and statistical principles. And then we're going to look at numerical and graphic relationships. So in order, I think, for this to be productive for you, I have a couple of suggestions. It would be really helpful if you had scrap paper in front of you so that you could solve problems as we go. If you would like a hard copy of the materials that we're working with, I believe those are available to you in the CBEST folder that Margaret shared. You don't have to print those out if you just want to work on scratch paper. For example, I have scratch paper beside me. That's what I'm going to be using as I'm working through some of these problems. You're welcome to do that. In order to facilitate this so you can actually see how I'm solving these problems, what I'm going to do is actually share a view of me solving. And so if, right, you need to increase your screen size, or if it's something where you need me to make it just a little bit bigger so that you can see, please don't hesitate to let me know. This is, I think, a great opportunity for us to be able to problem solve as we go. And so if there's something where you think, oh, it would be really helpful for me to be able to see, then by all means, please don't hesitate to let me know. So we're gonna get started. And I think there's probably 3 pieces of information that are really important when you're thinking about taking any standardized test. The first is we practice so that we can relax. It's so easy, I think, to go into an exam, and I am the first person to struggle with this and be anxious or nervous. But I have to remind myself when I go to take the standard tests that if I have practiced, then I'm not going to see anything that is new that I'm not ready for. And so we practice so that we can relax. And yes, I believe the recording will be available.
Yes, we should do it. We should be able to send it out after.
The second piece that I think is really important to consider is just the ability to pace yourself. So there are 50 problems on the math section. And I think for me, right, some of those problems are going to be problems that I'll be able to solve quickly, but there might be other problems where I'm going to want to take more time. And so if I think about pacing myself in terms of the amount of time that it takes me to solve those types of problems, then it's going to be really helpful if I have just either a watch with me or something that allows me to keep track of time so that I'm not spending too much time on one problem, right? And maybe not enough on another. And then the last piece of this is we want to be strategic. What we mean by being strategic is you need to pass the CBEST. And in order to pass the CBEST, you need 41 points. That's our goal for math. But that means that if we've got 50 problems, it's okay for us to miss some, right? We can miss 1 or 2 problems, get them wrong, and still pass. And so we can be strategic. And if there's a problem that we're really not certain about or not sure how to do, we can leave that until the end to make sure that we answer all of the other problems that we know how to do and are more successful that way. So that's going to be our strategy that we're using. There are a couple of pieces of information that is available from the CTC. We're not going to so much spend time on these today, but if you would like to go and review them, they're available in the packet. So for example, there are very specific test directions. So for example, right, that it's multiple choice and there are 5 answers, that we want to read each question carefully and choose one best answer. And then I imagine that most of you are going to be taking this as the computer test. So while you might be working your answers in terms of on scrap paper, you're probably going to be answering on a computer, but there's also a hard copy test, I think, that's also available. And so the really important thing here, and I think this is where it's so helpful to have these directions, is that it says you can work on the multiple choice questions in any order that you choose. We're going to start with number 1 and work all the way through. But you know what? You don't actually have to work in that order. If you wanted to start at the back and work towards the front, you could do that. Or if you wanted to think about a problem that, say, for example, you would do and then come back to because you want to make sure that you have enough time to really focus on it, that's totally fine too. So the most critical piece of information is that you have 1 4-hour session in which to complete whatever sections you've registered for. So that's probably the most important piece of information that's here, besides the fact that you can move between. Okay, we have 2 questions in the chat that I want to pause and answer for a moment. So it says, if you do not pass the math portion the first time, are you able to retake it? If so, how many times? So yes, if you do not pass the math portion, you are able to retake it. I don't think there is a limit on the number of times you can retake it. That's a good question that I'll have to follow up on because I'm not sure if there's a limit. I do know that we want you to be successful the first time you take it. And so our goal today is to both set you up with successful strategies, but also give you enough practice so that you feel comfortable with those types of problems. But yes, you are definitely able to retake the math portion if you need to. And then if testing will be available during this time or anytime soon in the future. So my understanding is that right now there is not a lot of open slots available, that essentially folks have signed up for CBEST and CSET testing. And so right now, it looks like folks are having to sign up in November because there aren't any summer slots open yet, or that ones that are open have been filled. So my guess is that because of social distancing, that's part of the reason for it.
I know that there are some testing sites that are open that are opening up this week, this upcoming week. So it's just a matter of finding out where is your testing site or where you want to go. and then call them to see if they're opening up. I know Paso Robles, I know that's far, but they actually continue to do testing, but only limited the amount of people in the room. So it varies on location.
Yep. So I think probably the best strategy is if you've already scheduled for a test, say for example, Cassandra was really helpful to provide some additional information saying that if you're registered and they cancel or move you forward to an alternate date, that's something you want to pay attention to. Great question from Taylor. You cannot use a calculator on the CBEST test. Now, here's the really good news about that. That means that whatever math they give you, right, has to be math that doesn't require a calculator. So in that way, we're going to practice some strategies to help. But I think it's definitely something that if you're used to doing math with a calculator, you definitely want to account for in terms of time. So as a quick recap, just to make sure that everyone's on the same page, there are testing sites that are available, but you really do have to contact the individual sites. And it depends upon location, whether or not they're currently offering tests or they will be offering tests in the future. I think the best way, I think, to follow up with that is if you already have a reservation, to contact that individual test site. And then for test accommodations, I believe that is a specific conversation with the site that is administering the test. So if there are specific individual questions in terms of taking the CBEST test, one of the things we can do is save some time at the end of our session. So if you have something that is specific or individual to you that you can ask, and we can provide some support to be able to answer those questions too. So if you are worrying about a specific scenario or you're concerned, say for example, about the timing, those are all questions that we will be able to spend some individual time with you and answer at the end. Okay, so while we're doing a paper-based test, it's important to recognize that you may be doing this on a computer as well. For our purposes today, if you want to keep track of your answers in terms of the question numbers and your responses, something like this is a great way to do that. I actually use this as a strategy for my review. So when I'm doing a practice test, what I typically do is I chunk the material. So we're going to do 10 question chunks. And then we're going to break out into our breakout sessions and share the strategies that we had that were really successful for solving these types of problems. And then what I do after that is once I've had a chance to reflect on what worked well, I go back and I identify the critical sections that need review. So I think of this as opportunities to iterate your learning. So we're never done learning. We always go in and refine to make better sense of what we're knowing. And so that's what we're going to do today is we're going to go through a process of iteration. So we're going to practice, we're going to do a problem, and then we're going to reflect, think about what worked in terms of how we solve that problem. We're going to seek out additional information if we need, and then we're going to go through another cycle of practicing again. So here we go. We're going to start with problem number 1. So problem number 1 says, during a semester, a student receives scores of 76, 80, 83, 71, 80, and 78 on 6 tests. What is the student's average score for these 6 tests? So for solving a problem like this, there are a couple of things that I'm going to do. I'm going to, take the sum of the numbers that I've been given, and in order to make my life a little bit easier, I'm going to think about patterns. So for example, I'm going to think about the fact that 6 and 3 is 9, and 1 is 10, and 10 and 8 is going to be 18. Then I can carry my 1. And then if I'm looking at the other numbers that I have, I know that I have 3 8s, so 3 times 8 is 24. And I know, that if I'm thinking about right, how I'm adding up these numbers, right, I want to make sure that my pattern is only, right, for the numbers in the tens range. So 7 and 8, that's going to be 15. 7 and 8, that's 15. And 7 and 8, that's 15. So the really lovely news here is I want to make sure I'm using the right pattern, in this case, addition, and I'm going to add these up, and that's going to give me, right, 15 plus 15 plus 15, or 45. And because I'm carrying the 1, it becomes 468. And so if I'm thinking about my pattern then, right, I've added up, I have the sum of all of my numbers. Now my average is going to be to take 468, and in order to get an average, I have to divide by the total number. So if I'm thinking about my number of options that I'm given, I have 1, 2, 3, 4, 5, 6. I'm going to divide by 6. Now, this is a really interesting moment where if I'm thinking about this test, the first number, right, will probably help me eliminate at least 1. So in this case, I know, right, that 6 times 8 is too many. So I can get rid of E. All the remainder of my numbers is 7. So that means that this number has to be 7. Now, I can either do that because I know the math, where I would say, well, 6 times 7 is 42. 6 times 8 is 48. But I can actually also use my answers as a help if I'm not as familiar with my multiples. Then I'm going to subtract, right? 6 goes into 48 8 times. That means my answer is going to be C. So there are a couple of ways that you can do patterns, right? I could do the pattern in terms of the multiples of 8 and the multiples of 7, right? So for example, 21 is 7 times 3, and 3 times 8 is 24. That gets me to 45. I could do the pattern of 8 plus 7 is 15, right? So there are several different ways that I could add these numbers quickly, even though I don't have a calculator. And some of that is really helping us think about patterns. So one of our strategies is to think about patterns. Let's take a look at number 2. It says, use the table below to answer the question that follows. So on the 3 sections of a math test, a student correctly answered the number of questions shown in the table above. What percent of the questions on the entire test did the student answer correctly? So this is going to require us to make sense of some information that's available. We're given the total number of questions, and we're given the number of questions correctly answered. So we have to do a little bit of work. The first piece of work that we need to do is figure out the total number of questions. So that means we're going to look at these numbers and add them together. And again, this is where thinking about patterns helps. So 5 and 5 is going to be 10. And if I have a 1 that I'm carrying over, I have 2 plus 2 plus 1 is 5, plus that additional 1. So I have 60 total. And then if I'm looking here, I know that this number, whatever it is, will have to be, right, also equal to or less than 60. And if I'm looking, there are a couple of ways I can do this. I can figure out how many fewer I've answered and subtract that from 60. So that's 3, that's 4, right? And then 5. So I could subtract that, right? And that would get me to my total, or I could add these up. So I could add 1 and 7 to get 8, and 1 plus 1 plus 2 gives me 4. So correct is equal to 48. But that's not all this problem is asking me to do. The other thing that this problem is asking me to do is to make sense of, right, what percent. So I know that percent is part of the whole. So in this case, I have to think about what is my part and what is my whole. Well, in this case, my total is going to be my whole. My part, or the number that is correct, is 48. Now, a percent, right, is usually out of 100. So I'm going to put 100 on the bottom, and I'm going to put X on the top because I don't know what my percent is. Now, there are a couple of ways that I can solve this. Okay? I could cross multiply and then divide. So I could do 4,800 divided by 60. So that's one option. Notice I can cancel my zeros, so that's the equivalent of 480 divided by 6. Right? So if I do that, right, 6 goes into 48 8 times. So that would give me 80%. But there are a couple of other ways that I can solve this problem that might actually be faster. So I want to make sure that we talk about those two options. So because 48 out of 60 is a fraction, I could think about, right, how could I simplify that fraction? So for example, is there something that goes into both of these? So what is, right, common for both 60 and 48? And I know that 12, right, so if I divided 48 by 12, I would get 4. And if I divided 60 by 12, I would get 5. And here's the really cool part. If I have a fraction that is fifths, and I'm thinking about how many go in to make 100, I know that in order to make 100, I need 20, right? So 5 times 20 is what gets me to 100. So if I multiply 4 by 20, that also gives me 80. So that's how I can also get to a percent. Here's the really cool part about most of these math problems. Can you see it better now? So there are multiple ways typically to solve this type of a problem. And so the goal is that you figure out for you what is the most efficient way to solve. So if you have a technique that you feel comfortable with, by all means use that. If there's a way where you can solve the problem and you can do it with a little bit more speed or efficiency and still get the correct answer, then by all means do that. So our goal is that we give you at least a couple of ways that you're able to solve these problems with some speed or efficiency. Okay, let's take a look at the next problem. We're going to use the diagram below to answer the question that follows. If the actual length of the bridge is 4,200 feet, then what is the scale of the diagram of the bridge? So this is going to require that I pay some attention to specifically my scale. And what's most important here is that my bridge starts not at 0, but at 1. So if I'm looking, here's 0, but the scale of the bridge goes from 1 to 6. So that's actually 5 units. So it's really important that we pay attention to our scale. So if the actual length of the bridge is 4,200 feet, then what we're saying is we're going to represent that 4,200 feet using each of these inch increments. And since I have 5 of them, I'm going to divide 4,200 by 5. So 5 goes into 42 8 times. That gives me 40. 5 goes into 24 times. So I have 840 feet then, right, that is represented by 1 unit, right? And so this looks like inches on a ruler. So in this case, my unit, whatever that is represented by 840 feet. So if we're thinking then about this problem and if there's another way to solve it, one of the ways that we can think about that is just making sure that we understand the whole. So this is a lot like that part and whole problem. So the part is 1 unit, the whole is 4,200 feet. And so that's another way that we can think about approaching this problem. All right. Let's take a look at number 4. This is a slightly different type of problem. Number 4 says, which of the following is the most appropriate unit for expressing the weight of a pencil? So we have pounds, we have ounces, we have quarts, we have pints, we have tons. So in this case, it's probably helpful if you can think about something, right, that is an object that would be equivalent to this type of weight. So when I think of pounds, right, I think, say, for example, of the dog food, right? A 50-pound bag of dog food is pretty big, right? So I'm probably not going to be using pounds, not for a pencil, because pounds is pretty significant. Another example of pounds might be, say, for example, if you go to the grocery store and you get 2 pounds of flour. Ounces is not a bad choice, right? Because ounces is pretty small. It's something that we can use both as a weight measurement and as a liquid measurement. In this case, it would be a weight measurement for the pencil. So I'm going to hold and say, I think B might be a good option for the weight of a pencil. Quarts is what we use to measure a liquid, say, for example, a quart of milk. The same thing is true for pints. So because the pencil is not a liquid, I know that I can get rid of both of those. Tons is like the weight of a car. So I think tons is too big for a pencil. So we're definitely going to exclude that, which leaves us with B, ounces, as our best option. So this is an example of a problem where you don't necessarily have to know right away what the correct answer is. In fact, what they're expecting you to do is use your reasoning skills. And so if one of these words or terms is something that we're not familiar with, then our best bet is to come up with either flashcards or a way that we can familiarize ourselves with the terms so that when we see them again, we either have an analogy, something we can draw on from our prior knowledge, or, right, if, say, for example, we're thinking about working with students, sometimes being able to give them an example or help them come up with an example of what makes the most sense to them is really appropriate. All right. Let's take a look at problem number 5. So it says, Ms. Gutierrez needs to order rope for her gym class of 32 students. Each student will receive a piece of rope that is 5 feet, 8 inches long. What is the total length of rope, excuse me, that Ms. Gutierrez needs to order for her class? So if each student receives 5 feet, 8 inches. So this notation is the notation for feet. This notation is the notation for inches. And if this is each student, then I need to multiply 32 by each of these. So 32 times 5 is 160. So I have 160 feet. And then 32 times 8. So I have 2 times 8 is 16. So I have a 6. I carry the 1. 3 times 8 is 24. I add the 1. So that's 256. But I know that this is in inches and this is feet. And so in 1 foot, there are 12 inches. So I can divide 256 by 12. And that's going to tell me, so 2 times 12 is 24. 12 goes into 16 once, and I have a remainder of 4 inches. So then if I think about this, I'm going to have 160 plus 21, which equals 181 feet, and then 4 inches, which is my remainder. So if I'm looking at my answers here, my answer is D. Part of what I want you to think about is the fact that even if you weren't completely confident in terms of, right, the second step where you're dividing to figure out the number of, say, for example, inches that are in a foot, you could go ahead and actually eliminate most of these answers. So you wouldn't necessarily have to solve the problem completely in order to check to see whether or not you're on the right track. For example, just by getting to this point, there are several problem answers that we can eliminate, right? So we can eliminate 106, we can eliminate 154, and we can eliminate 160, because all of those are answers that are smaller than the 160 feet, and we actually have inches in addition to that. Then, right, if we were trying to figure this out, right, by determining the number then of feet, right, in our inches, that would be what allows us to tell the difference between D and E. But if, say, for example, we were running short on time and this was one of the problems that we hadn't gotten to because we weren't confident in the conversion between feet and inches, right, then at least by simplifying, right, or removing answers, we could, right, have only 2 to choose from, and 50% is far better in terms of best guess, right, than having to choose out of 5. Okay. So if we're thinking about, right, how we solve these types of problems, let's take a look at number 6. So use the diagram below to answer the question that follows. What is the total length of Clear Lake's shoreline? So the first thing that I have to think about is, what is shoreline? So shoreline is the edge, right? And I'm counting the total edge. And in this case, I'm given some information that's going to help me. I'm given that one length, I have 1, 2, 3, 4, 5. So that means that one length is equal to 2 miles. So I'm going to count my edges. And for me, I'm going to use dots to help keep track. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I have a total of 22 sides, right? But because this is 2 miles, I have to multiply that by 2. That's going to give me 44 miles. So my answer is going to be B. Now, there might be other ways that you could solve this problem. So, for example, you could figure out, right, the total number of blocks. So in this case, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And I could figure out by subtracting the shaded area from the edge if I'm thinking about areas. There's actually several different ways that you might be able to use a diagram to help you make sense of solving a problem. I think this is the most efficient. Ooh, great question. Someone said, how did you get to 2 miles again? If I look at my scale, I'm starting at 0 and it goes to 20. And if I count, I have 1, 2, 3, 4, 5. So each line then, right, if I take 10 divided by 5, each line has to represent 2. That's how I get the scale. So my scale is equal to 2 miles. The other way that I could do that is I could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 20 divided by 10 is also 2. So if it's easier to do that, that's another option. All right. We're over halfway there. Let's talk about number 7. So we're going to use the diagram below to answer the question that follows. A glass tabletop is supported by a rectangular pedestal. If the tabletop is 8 inches wider than the pedestal on each side, what is the perimeter of the glass tabletop? So let's think about this for a moment. Perimeter is the outside. So perimeter is going to be length plus width plus length plus width, or 2 times length plus 2 times width. But in this problem, they tell us that the tabletop is 8 inches wider on each side. So that means that I'm going to take 36 and add 8, not just on one side, but on both sides. And then I'm going to take, and that's going to be my width. For my length, I'm going to take 48, and I'm going to add 8 on both sides. So if I think about that, then my width is going to be 52, so 36 plus 16, that's 12, carry the 1, so that's 52 is equal to my width. And my length in this case, so 48 plus 16 is going to be 64. That's going to be equal to my length. So in this case, they want the perimeter of the glass tabletop. So that's the same thing as saying 52 plus 52 plus 64 plus 64. And so these combine, and that's 10, 10 and 2, so 12, carry the 1. 5 and 5 is 10, 6 and 6 is 12, so 22, so 2, 3, 2. That means that E, right, and we check because inches, right, is the same measure that they used here, so we know we're using the right unit. So 232 is the correct perimeter. And there are other ways, right? So maybe if you didn't feel comfortable with adding, you could multiply instead. So you could do 52 times 2, and you could do 64 times 2, and then add those together. So 4, 104, 8, 128. So 104 plus 128, 2, carry the 1, 32, still gets me to the same answer. And so that there are multiple ways then that you could think about using arithmetic to be able to solve this type of problem. Okay, number 8. Rob uses 1 box of cat food every 5 days to feed his cats. Approximately how many boxes of cat food does he have per month? So this is a problem where we're going to have to make some sense of the information that we're given. So for example, we're told 1 box per 5 days. And then we're also told, right, how many boxes per month. So we're looking for the number of days in a month. And we're going to try and solve for the number of boxes of cat food. So if I think about this, I could cross multiply, right? So 30 divided by 5, right, would allow me to say, okay, that means it's got to be 6 days. So if I have 1 over 5, that's the same thing as 6 over 30. So that's one way that I could solve that problem. Another way, though, that I could solve that problem, right, is something they call unit conversion. So I could say 1 box per 5 days. And I could say, all right, there are 30 days in 1 month. My days cancel, right? 30 divided by 5, right? So I have 6 boxes per month. That's another way that I can solve that problem. Both are equally reasonable approaches, but I think it's really going to be up to you to determine which one is the most helpful or efficient for you. Okay. Let's take a look at number 9. So Tara can develop 2 rolls of film in about 18 minutes. At this rate, how long will it take her to develop 8 rolls of film? So if we're thinking about the information that we're given here, it's a similar setup to the problem that we just solved. In this case, though, right, we're told we have 2 rolls of film, and it's 18 minutes. And then we're told now that she has 8 rolls of film. So in this case, we're solving for what's in the denominator. And that's gonna, right, be something where we use the same approach. We can cross multiply, right? Or, right, we can think about how to simplify. So let's do a little bit of simplification. So I can simplify this. So 2 can go into 18. So that's the same thing as 1/9. Right? So 9 times 8 is 72. So it's 72 minutes. Right? But if I take a look at my answers, this is in hours and minutes. So I need to convert 72 minutes. So I know that there are 60 minutes. So I'm going to subtract 60 minutes in an hour. And that leaves me with 12. So the answer is going to be 1 hour and 12 minutes. Again, this is a great example of a problem that you could solve multiple ways. Probably the most important part is that you're thinking about how the answer is given, whether it's given in minutes or given in hours and minutes or given just in hours, and then determining your strategy from there. All right, let's take a look at number 10. So Liliana has a bag of marbles. The bag contains 18 black, 15 red, 11 blue. Ooh, sorry, we had a question. Let me go back for a minute. How did I get 72? So if I take a look here, remember, I can cross multiply. So I have 9 here. 9 times 8 is 72. That's how I actually get. So if I cross multiply these 2 numbers, that's how I can get 72. The other way that I can think about that, right, is if I think about 8 as my 1, right, what would 8, right, be a part of in terms of the whole? So what's my whole? In order for 8 to be a 1, I'd have to multiply 8 by 9 in order to get my whole. So my whole in this case is 72 minutes. So 8 rolls of film relative to my 72. Oops, sorry. All right. Let's take a look at the problem again. I'm sorry. This is a good example of I read it, but I think I need to read it again. And that's okay. It's not a problem to go back and reread a problem, especially if the first time you read it, it didn't make sense. So it says Liliana has a bag of marbles. The bag contains 18 black, 15 red, 11 blue, and 8 white marbles. The first thing I'm going to do is I'm going to figure out my total number of marbles. So I've got 18 plus 15 plus 11 plus 8. So right now, if I'm thinking about my total number of marbles, right, I'm going to add these together. So 8 and 8 is 16, right? Plus 1 is 17, plus 5 is 22. Carry my 2. 2 plus 1 plus 1. So I've got 52. So I've got 52 marbles total. Then it says Liliana randomly takes a red marble from the bag and leaves the marble on a table. So now let's think about this. So if this is black, this is red, this is blue, and this is white. Okay, so it says she takes 1 red marble from the bag. What is the probability that she will take a red or a white marble from the bag? Okay, so by taking 1 out, I now know that I have 51 marbles, and that's going to be important because I have to know my total. And then probability just says how many. So out of my total, again, this goes back to my part and whole. So 51 is my whole. And the part that we're thinking about in terms of probability is red or a white. So what's the probability that I take a red marble out of the bag? Well, I have 14 red marbles. So 14 out of 51. And a white marble. So I have 8 white out of 51. And so if I'm thinking then about how I determine, right, I'm able to say, okay, 14, right, plus 8, right, what's my total there? So 2, right, is 12. So I have 12. I'm going to carry the 1. So I have 22. So 22 out of 51, right, or D, is my probability. So because this is an or, I'm only drawing out 1 marble, I can add these 2 together. So if, right, I know my number of red marbles and I know my number of white marbles, I'm just adding these 2 fractions together. They have a common denominator, so all I really have to do is just add the numbers in the numerator at the top. Okay, so we just did the first 10 problems out of 50. Here's what I'd like for you to do. I'm going to randomly sort you into breakout rooms. The purpose of the breakout room is for you to think about these 10 problems that we solved. And I would love for you to have a conversation with the people in your breakout room about the following. What were the problems that you felt really comfortable solving? And what were the strategies that you used, right? How were you successful in solving those problems? But then the most important part of this conversation is, what were the problems that maybe you didn't feel as comfortable solving, and what might be strategies that you could use to solve those problems? So I'm going to sort you into breakout rooms. Oh, yes, Cassandra, thanks for your clarifying question. When you have probability problems and they use the word or, it means you're going to add the 2 fractions together. That is correct. So I'm going to sort you into breakout rooms, and I'm going to move between the breakout rooms to help facilitate. So if you have questions, say, for example, there was a problem that we went through and you're like, hey, wait, why did you do that? Or, right, you're thinking about a strategy that you want to use to solve and you need a little bit more clarification, not a problem. My goal will be to roam through those rooms. But the goal is for you to actually do the talking with your colleagues, with your fellow future teachers, to think about, okay, what was it that I knew how to do well? And then what might be the spaces where I still need additional practice? And then use each other as resources to help make sense of how you solve those problems. So here we go. I'm going to sort us into breakout rooms. You should be invited. Please, if you can, use video so that your fellow participants can see you. If, say, for example, you're in a space where internet's rough and you can't do that, that's okay, no worries. Just be mindful to participate in the conversation. So if you're not sure how to use a breakout room, I'm going to open all rooms, and literally you're just going to go into that space, and then I'll invite us back into the main room in about 10 minutes. And that should give me enough time to go and check on everybody in each of the breakout rooms. If you're not sure, you should be able to just click and join the breakout room. That way, if there's someone who doesn't have a room, I'll make sure to assign you to one. Okay. And anyone who has not joined, if you're not sure how to do that, please don't hesitate to ask. I can help. Okay. All right. I'm going to go ahead and check on breakout rooms. We'll be back.
I didn't get assigned to one.
Ooh, you should be assigned. Let's see. I don't have any unassigned. Let's see. Sarah is breakout room 1. And Michelle is breakout room 5.
I didn't see a thing to join. My internet kicked me out, and then I had to
Oh,
come back
gotcha.
in.
Okay.
So
Let me. I will
Okay,
move you,
Sarah,
and then you
Sarah,
can
if
join.
you, okay, because if you click breakout room at the bottom, it'll tell you what breakout room you're in.
oh,
I
I
don't know
didn't
if
see
you,
that. Okay, never mind.
Okay. Very good. Okay. Let's go check.
Corinne, you're muted.
All right, we're gonna go ahead and take another 10 problems. Hopefully this is an okay pace. If it's too fast or too slow, just let us know in the chat. Hopefully your conversations were productive as you reflected on your learning. It makes such a big difference to have those conversations and think about the strategies that you're going to use as you go into the future, because we both want to think about this both in terms of how you solve these problems, but also the way you're going to help your students solve these problems, because we know that for many of the students that you're going to encounter, you are going to be their best asset for helping make sense of this information. And so we both want to think about ways we can completely solve these problems so we understand the math behind it, but we also want to think about strategies we can use that will help us be efficient as we're taking the test to make best use of time. So that's our goal, is to do both of those things today. So let's take a look at number 11. So at a college, approximately 2 out of 5 seniors go on to attend graduate school. If there are 750 seniors at the college, how many would be expected to attend graduate school? So this is a great example of a problem where, again, we've got a ratio. So we have 2 out of 5. So again, this is our part out of the whole. It's a 2 out of 5 seniors. And then they say, okay, if there are 750 seniors at the college, how many would you expect to attend graduate school? So we have 750 total. That's our whole. And we need to figure out our part. So there are a couple of ways that we can do this, right, that will help simplify the math. So if we're thinking about this in terms of, right, we can multiply these two together. So 2 times 750, right? And then divide by 5. That's one strategy that we can use. The other strategy that we can use, right, is to think, okay, if I take 5 and divide that into 750, how many is that? So 5 goes into 75 15 times. So, right, gives me, right, 150. Now, if I simplify to 150, then I can multiply 150 by 2, and that tells me that x is 300. So there are 2 ways that I can solve this problem. I can do it where I multiply, so 750 times 2, 0, carry the 1, and I get 1500, and then I have to take 1500, right, and I divide it by 5. 5 goes into that, and that's 300. So that's the other way that I can get 300. Both of them are perfectly reasonable and valid as a way to solve the problem. Some of it is up to you in terms of which one is more intuitive or which one makes more sense. Let's take a look at number 12. The Mills Library, so the 300, right, came from 2 places, right? So again, this is the part over whole, so I have 2 over 5, which is equal to x over 750. So remember, I can cross multiply. Cross multiply means 2 times 750 is what's going to go over here. And then x times 5, and that's what's going to go over here. So that's one way that I can solve this problem, is to say, okay, right, 2 times 750 is equal to 5x. Right, so that's the math that I did over here. Right, so 2 times 750 is 1500. And then I have to divide both sides by 5 to get x by itself. So 1500 divided by 5 gives me 300. So that's one approach that I can use. But the other approach that I can use is I can simplify my terms, right? So in this case, I know that 5, right, can go into 750. So 5 times, right, 150 gives me 750. And so I can then take that 150 and multiply it by 2, and that will also give me 300. So both of those are options. Either one is feasible when it comes to solving this problem. Some of it is, again, which one makes more sense for you. But it's a cross multiplication problem is the best way, I think, to think about number 11. Okay, what about number 12? So it says the Mills Library has 1,007,199 books. The Springvale Library has 907,082 books. Which of the following is the best estimate of how many more books the Mills Library has than the Springvale Library? Okay, so let's think about this. I've got 1,007,999, and I've got 9,082. So if I'm thinking about estimates, I want to see a couple of things. I want to see that these numbers are pretty similar. 1,000. So I'm ignore. Then the biggest difference between 900,000 and a million would be 100,000 books. So because this is an estimate, I want to be able to round. And so essentially what I'm saying here is there's not a significant difference between, right, 200 and 100, right? At least not in terms of an estimate. And because it's 7,000 is the same for both, I'm going to ignore those numbers. The biggest difference is between 1,000,000 and 900,000. And so that is 100,000 books. And so in some ways, it's the answers that I'm given, right, that allow me to make this choice. So for example, I know that it can't be 1,000 books. That's not a reasonable answer. And I know that it's not going to be 8,000 books because none of these numbers are going to round to 8,000. 7,199, if I were to round, that'd be 7,200. That's not going to round to 8,000. And 82 would round to maybe 100, so 7,100, that's not going to round to 8,000. So I can ignore that. This is maybe where it gets a little bit trickier because I have to actually think about place. So here, right, the tens value, right? Well, 10 isn't actually going to get me up to 1,000,000. It actually needs to be 100. So this is a red herring. It's just if you didn't know your place in terms of ones, tens, or hundreds. And then 80,000 books, right? You might be tempted to think about this if you were doing the math to actually subtract them, but 100,000 is by far your best estimate. Okay, let's take a look at 13. Which of the following is the best estimate for 4,286 times 390? So I'm going to think about how I can round here. So I'm going to round this number to 4,000. And I'm going to round this number to 400. If I do that and I multiply these two together, right, then I have 16, right, and I have 5 zeros. So notice 1, 2, 3, 4, 5. So that's where my 5 zeros come from. 4 times 4 is my 16. So the answer is B. Now you could estimate, right, and right, use another term. So you could do, say, for example, 4,200, right, and 400 here. But I actually think this is the easier math to do. And since it gives you the answer, I think that's your better bet. And again, for estimating, all that's really asking you to do is round and think about what is the most reasonable or likely answer that you're going to see. Okay, let's take a look at 14. So it says the lowest point on the Earth is the bottom of the Mariana Trench at a depth of 35 840 feet below, we're going to say this is sea level. The highest point on Earth is the summit of Mount Everest at a height of 29,028 feet. And it says, which of the following is the best estimate of the distance between the highest or the lowest and the highest points on Earth? So if I'm thinking about that, right, the distance is actually that length. So I'm going to want to add those two numbers together, right? But I'm going to do an estimate here, right? So because they ignore the places here, I'm going to round this up and say, okay, I have 36,000 feet plus 29,000 feet, right? 5, 1. And so I have 65,000 feet. And so if I'm thinking about that, I can use estimation to round. I'm going to round to get this number. And I'm going to round down to get this number. And then when I add them together, that's what's going to give me 65,000. Now you could, if you're really worried about, right, whether or not you rounded it correctly, you could actually do the math to add them up, but that might take a little bit more time. So this would be something where I would do my estimate, and then if I had time at the end, I would come back and check. Okay, ooh, sorry, too far. So Kim is in the 10th grade and takes a standardized test. Use his test scores below to answer the question that follows. So Kim's test score indicate. So let's take a look. We have his raw score. So that's just the number of points that he scored out of the total. We have the percentile. That's how his score is converted in terms of the percent. Right? We have his standing. So this is how they convert essentially percentiles to a 9-point scale. And so it says that he scored on the 8th of those 9 points. And then the grade equivalent is 12.1. So let's think about the information and what's available. So it says he scored as well or better than 72 of the test takers. Well, that's not true because they don't actually give us the number of test takers. So we can ignore A. If we think about B, 28% of the test takers scored better than he did. We don't know that, right? So we can ignore that. He would perform adequately in a 12th grade science class. Again, this is something where we don't actually know, right? We know his grade equivalent, but we don't know what that would mean in terms of his performance. He scored as well or better than 88% of the test takers. That is correct because that's what this word percentile, right, and 88 means. And then E, he answered 72% of the questions correctly. Well, again, E is not an option because it's not a percent. 72 is his raw score. So in this case, D is the only available answer. All right, let's take a look at number 16. The expression -105 plus -14 plus 34 simplifies to which of the following? Okay, there are many different ways to solve this problem. I'm just going to show you my favorite. So I feel like the easiest way to approach this is to say, okay, -14 and 34, that's the same thing as saying, right, 34 minus 14. So that means I'm going to have a positive 20. So positive 20 and -105. Right? If I think about adding those together, is going to be a -85, which is the answer that is here. But there are other ways that you could have done this problem. So for example, you could have combined 105 and -14, right? that would have given you negative 119. And negative 119 plus 34, right? You could have done that math. But this one makes a little bit more sense to me, but either one would still get you to 85 or negative 85. Most important thing is to make sure that you are paying attention to your signs. So this is, right, your negative sign. This is a negative sign, right? And then 34 would be positive. So a couple of different approaches, right? Pick the one that I think would work best, or pick the one that you think, excuse me, would work best for you. Okay, let's take a look at 17. Use the information below to answer the question that follows. As part of a unit on weather, students recorded the outdoor temperature at 8:30 a.m. for 5 mornings. What was the difference between the week's highest and lowest morning temperatures? So this is where I'm going to have to read information, right, in order to make sense of it. And so in order to do that, I want to make sure that I'm reading correctly. So what is the lowest temperature that's here? The lowest temperature is negative 15. The highest temperature is 12. So if I think about that, I have to travel 15 units to get to 0. And then I have to travel an additional 12 units to get to 12. So if I add 15 and 12, that gives me 27 degrees Celsius, which is E. I want to go back because someone asked a question about the negative 14. And so in this case, it's really important. This parentheses doesn't change the operation because here we're only doing addition, right? So the parentheses is really to show us that we have a negative number, right? And so we are adding negative 105 plus a negative 14 plus 34. And so we don't actually have to convert that negative as much as we have to be mindful of the fact that when we add negatives together, they keep the negative sign. Whereas if we were to add a negative to a positive, we'd have to think about which of those two is the larger number, and that would determine whether it's positive or negative. Okay, so let's go back to problem 18. So a teacher has 3 packages of stickers. One package contains 56 stickers. Another package contains 48 stickers, and the third package contains 58 stickers. If the teacher divides all of the stickers equally among 27 students, how many stickers will each student have? Okay, so let's think about this. We have 56, we have 48, and we have 58 stickers. So if I add that together, so that's 16, 16 and 6 is 2, carry the 1, 5. So I have 162 stickers total. I am not done yet though, because it says divides all the stickers equally among 27 students. So 162 divided by 27. And so if I think about this, right, now I can do some elimination. Right, so let's think about it. If, right, I'm thinking about the answers, well, I know it's definitely not E because 162 is the total number of stickers. And in this case, the problem is really clearly asking how many stickers will each student receive. So I know E isn't an answer. And since I know I have 27 students, right, I know that 81 can't be the answer. And, right, 54 is not a reasonable answer. So now I'm stuck looking at 6 and 9. Well, if I think about it, right, 6 times 20, right, would be 120. And then 9, right, if I think about 9 times 20, 180. So if I'm thinking about this in terms of options, right, 180 is too much. So that means it has to be 6. And if I wanted to, I could check my math. 27 times 6, right? So that's 42, carry the 4. 2 times 6 is 12, plus 4 is 162. So I've checked my math. Great question. So if we are, right, thinking about 152, let me check. Hold on. Maybe I miswrote. 8 and 8 is 16. 16 and 6 is 2. Carry the 1. 5. Oh, you're right. Should be 152. Sorry about that. 5 and 5. Oh, I know why. That's because it should be 2. Right? Because 16 plus 6 is 22. That's why. Sorry about that. So you're carrying a 2 instead of a 1. So it's still 62. So 5 and 5 is 10. 4 and 2 is 6. Yeah. Great question. Sorry about that. So you're carrying the 2. Okay. Let's take a look at number 19. What is the tens digit in the dividend of the problem below? Okay. So they're asking us to figure out if we have a remainder of 23, right? We have to figure out the tens. So a good way to think about this is I'm figuring out what it is that I'm dividing, right, by 25, that when I multiply, right, gives me a remainder. So 5 times 25. Ooh, answer is A for number 18. Sorry about that. And the answer to number 17 is E, 27. Okay, so there are 2 ways to think about doing this problem. 25 times 5. Well, if I think about that, right, 25 times 4 is 100. So 25 times 5 would be 125. 125 plus 23 is 148. So the tens digit in this case would be a 4. So the dividend, right, is referring to this number. The dividend is what's getting divided. So 25 into this number, and I can double check, right? So if I do 148 divided by 25, right, I know that 25 times 6, right, is 150. So that's too much, right? So instead, it would have to be 25 times 5. That's 125. If I subtract, that gives me 3 and 23. So 23 is my remainder, which checks so I know that I have the right answer. So the correct answer to 19 would be 4. Okay, let's do problem 20. So last week, Mario walked 7 3/4 miles. This week, he walked 15 5/6 miles. What's the difference between the distance he walked this week and the distance he walked last week? Okay, so in this case, I have, right, mixed fractions. So I need to find something that will allow me to compare the 2. So because 6 and 4 are not a common denominator, I need to find a common denominator. So I'm going to choose 12 because that's an easy one. So how do I go to 12ths? Well, in this case, I would need to multiply here by 2 on the top and 2 on the bottom. So that would be 10 twelfths. So 15 and 10 twelfths. And then here, in order to get to twelfths, I would need to multiply by 3. So 9 twelfths. So 15 minus 7. Okay, so I have 8. And then 10 minus 9 is 1/12. So the answer is 8 and 1/12 miles. The answer to number 19 is C. Thanks, Dana. Okay, I'm gonna break you out into breakout rooms again. And your task is, again, to have that conversation of what were the ones that you were comfortable solving and what strategies did you use? How were you successful? And then identify which are the ones that you got stuck on, which might be the ones where you need either some additional review or clarification. So if there was something that I solved and the step for solving it didn't make sense, go ahead and let me know. So I'm gonna open all rooms. Go ahead and have a conversation. Talk through what it was that you made sense of as you were solving and what might be something that you need to revisit.
Hey,
Hey,
let's see. Could go through them like one by one.
Hey, Blaze.
what's up, Melinda?
Oh my God, I don't see anybody's face. I totally went in, got kicked out here, and okay, please wait to be assigned. That's so weird, because I got kicked out and then I came back in. That's
Oh,
weird.
no.
So what do you guys think?
Everything looks
Who
good.
had problems?
I think they're gonna be like simpler. I try to like do them too quickly without really reading a lot of the stuff. Like number 14, for example, when it's asking for the difference between the lowest point and the highest point, I just kind of automatically assumed the difference, between the two numbers, not necessarily thinking about like to 0 and then from 0 again. So just really like reading the questions for me.
Yeah, I did. That was also what the I got E on that 14.
Yep.
My estimation was a little bit off. How about Clarissa? How about you? That's weird. I can't hear her.
Are there any other ones that people had trouble with?
Yeah, mine was geez. Not really. I've been getting pretty familiar with these.
Yeah, these ones are a little better. Yeah, I think 19. I had a little trouble at the beginning, but then kind of figured it out. But
Yeah,
I think just the
yeah,
layout.
19 too for me.
I think just the way it looks is a little different.
Oh yeah.
Kind of just interpreting like what it means.
Yeah. So like it would be 5 times 25, then add the 23
Yep.
to it. 48. Yeah, wait, 25. And then to make it up to 23 more remaining. So yeah, that makes so much sense now. I kind of got it a little bit off there.
Yeah, I never seen a problem like that.
All in all, it looks pretty, pretty basic.
Mm.
Oh, and then I wasn't sure about what stand is on 15, but I understood
Yeah,
that
I'm not sure.
it's a reasoning type of question.
Stand.
Blaze, do you guys know what standing means?
I don't know what it means. That one I kind of did like process of elimination.
Yeah,
Like
perfect.
should
Yeah, the
do.
reasoning part. Yeah,
Yeah.
common sense. I think that, yeah.
And it didn't say anything like regarding that 8, the number 8. So I just kind of like dismissed it.
Yeah. Anything else? How about you, Clarissa? Anything else? Or, oh, we've got a lot in our group here.
Yeah, there's 8 of us.
Oh my God, I didn't realize. Does anybody else have a issue with any of them?
I did with I don't know if you guys remember, but let's say adding the negative plus the negative, I don't remember how to do that.
I always
Oh.
go,
But I don't remember, okay, so if it's a negative and then you add another negative, what if it's a negative and you add a positive? What's it gonna be?
it's going to be a negative. Yeah, I always just think positive plus negative, always the negative will go negative.
Okay.
Yeah.
I always go,
So if it's
like if you're in a good mood, positive, we're in a good mood, but when we get a bad news, it makes a bad day for me. But then,
okay. Yeah.
but then I'll go, if a negative plus a negative,
Mm-hmm.
I mean, yeah, a negative, that makes me in a worse mood. So I'm going to do some exercise to make myself positive. So that means negative equals a positive, right?
Yeah.
Or no, but if you're doing addition, you're gonna go.
Well, yeah, I'm talking about addition. Yeah.
Yeah, negative with the negative, negative 8 minus negative 8. So you just go like on that timeline, on the line, you think about the 0 here, and this is negative 8. Now you're going to add another 8 negatives. So you're going to go to.
Also, it'd be go to the left.
Negative 16.
Okay. Okay.
So I go, this is the positive side. This is negative side. And we go 8 this way. And then we want another 8 plus negative 8. Yeah. You guys. I love my wife on board.
Yeah.
Who else? Do you have any more questions?
I think that was it. Let me see.
Pardon? Anybody else have any other questions?
Oh, I feel like you went really fast on number 17.
Oh, 17? Oh, okay. So right there, we can just do this one. I always go, like, this is my thermometer.
Okay.
She's not my teacher. She's batshit.
And then we've got 0 degrees. And they want to have the difference. I mean, the how many increase, right?
Oh, sweet. Yes, finally. Okay. That means
What was the difference between the week's highest and lowest? And so we're just gonna go, what's the lowest it's gone is 15 degrees. And then what's the highest?
12.
What do you think?
The 12.
Yeah, the 12. So 12. And now we've got all of this in between. So we just have to go, how many degrees to get to 0? 15. Now we're gonna plus how much from here to 12? 12. And so we add those two up to make sure that we get all the degrees.
Okay. Thank you.
So that's 27. And then what is that number? Oh yeah, number E.
Yeah, letter E. Yeah.
I hope that's kind of, I'm so sloppy.
I got it. I understood it better. Yeah.
Okay,
That
good.
looks good.
I think it was a great explanation to me. I thought it was awesome.
Yeah.
Okay. I can't wait to be a teacher in my middle of my life.
Hey, I think it's awesome. We need good teachers. We're so excited by having y'all. You are such an asset. I feel like that is one of the most important pieces. We need good teachers.
Oh,
All
good.
of our kids, each and every one, right, deserves a great teacher. So
Melinda,
they're going to be really lucky to have you.
Oh, we're back
All right,
into
so-
the group, huh? I'm sorry.
Everybody's back.
Okay.
So we're going to move forward and we're going to do the next set. So here's what I want you to think about. If you're doing the math test, right, and you find yourself fatiguing, and if you find yourself on Zoom fatiguing, it's great. It's totally acceptable to like stretch, to move, to get some blood flowing. If you need to just like stand up for a moment, you can do that. You don't have to remain seated, right? If a stretch would help you or a sip of water would help you, by all means, right, do what's going to help you to focus, right? You don't have to sit and answer problems uninterrupted, right, from 1 until 50. You can take a break if you need to. So we're going to take a look at problem 21. So it says a sporting goods store is offering a 10% discount on inline skates that normally cost $110.99. How much will the inline skates cost with the discount, not including tax? So to solve this problem, we're going to do a couple of things. We need to take the information that's given in the problem and make sense of it. So the first piece of information that we're given is a 10% discount. Remember that a percent is just the part of the whole, and so that's 10 out of 100. The skates normally cost 110. So we're going to say we have 110 and 99. So we're looking for what is 10% of this number. But here's the trick. We can do this math. So for example, you can multiply by 10, right? And then divide by 100. But if you think about your percent, right? So 10% is also the same thing as 0.10. And if we think about dividing by 10, right? We can just move a decimal place. This is the power. It's the power of 0.1 is that I'm literally just moving a decimal place by 1. And so the question then becomes, am I moving it to the right or am I moving it to the left? And so in this case, right, I'm going to move it to the left because I'm dividing by. So 10% of 110 and 99. Now, if I'm thinking about this from a math standpoint, right, think about what it is that you're doing. So in this case, right, if this is 10% of the total, what do you need to do? Well, you need to subtract this number, right, from your total. So this is the first step, is to find the percent, right? And then the second step is to subtract it. So in this case, I have 110, 99 minus 11.099. So if we think about, right, then the math that we have to do, right, let's think about how we set up this problem. Now, delightful news for you, right, you can go back to your original answers and you might be able to eliminate most of these, right? So for example, right, I know that I can eliminate 122, right? Because if it's a discount, it shouldn't cost more than 110, right? It's a 10% discount, right? So it should be more than just subtracting $1, right? So I can get rid of D2, and, right, I can get rid of C because, right, that's not a significant enough reduction. It's not 10%. So that leaves me with A and B. And this is where step 2, we're doing the math, really matters, right? So if I think about this, right, here is, right, I've got my 299. So I know that that's my answer. Let's take a look about what we have to do here. So in order to be able to subtract, right, so I'm going to borrow, that's a 1. And then here, right, I can't subtract 9 from 8. So I have to that into an 8, that 18. So 18 minus 9, 9. Right, and then this becomes 8. And I have to borrow from here. 10 minus 1 is 9. Right, and then 10 minus 1 is also 9. So my answer then is going to be A, 99.89. So you could pretty easily figure out, right, the percent, how much you need to subtract. But don't forget about this second step where you actually have to subtract it in order to get the correct answer. Okay, let's take a look at number 22. So at the beginning of a class period, half of the students in a class go to the library. Later in the period, half of the students go to the computer lab. If there are 8 students remaining in the class, how many students were originally in the class? Okay, this is a great example of a problem where you might actually need to do some backwards thinking. So let's draw out what we know so far. So it says there are 8 students remaining in the class. That's our end point. Okay, so it says later in the period, half of the remaining students go to the computer lab. Okay, well, if it's half, right, 8 times 2, if 8 is half, 8 plus 8 means that I have to go to 16 students. So that's the number, right? So this is in class, right? Half of the students go to the computer lab. So this is computer lab. Right? And then it says half of the students go to the library. Well, 16 plus 16 is 32. Right? So if I take half of 32 and they go to the library, right? Half of the students go to the computer lab. So, right, 16 students remaining, half of those go to the computer lab. So 8 go to the computer lab and then 8 stay in class. So the answer is 32 students. you could, right, solve this problem going backwards, or you could also have taken the information that was available and see if it would work. If you use the available information, say for example, you started with 12, let's see what that would look like. So if I tried 12, right, if I have 12 and half go to the library, that's 6, right? That leaves me with 6. So already I know that A can't be the answer because I know that I have 8 remaining and I haven't even done the second step. Let's try 16. So if I take 16 and half go, it gives me 8. I have 8, but it's the same problem. I still have to take that and divide it in half again. So I know that 16 isn't the answer. I could try it with 24. So half is 12, half is 12. And then I divide that in half, that gets to 6. So that's not going to work. Right? So at that point, I'm left with 32 and 40. And I could actually test out my strategy. If I used my strategy with 32, I would get to 8. So that would be another way I could solve the problem. Let's think about problem number 23. Okay, so this problem says, Peter works 38 hours per week and earns $7.25 per hour. His employer gives him a raise that increases his weekly gross pay to $307.80. So, what is the increase in Peter's weekly gross pay? All right, so let's take the information that's given in the problem and make sense of that. So, he works 38 hours per week and earns $7.25. So let's do that math first. Okay, so $7.25 times 38. So 8 times 5 is 40. Carry the 4. 8 times 2 is 16. 16 plus 4 is 20. 8 times 7, right? Plus 2, so that's 58. And then, right, I have my placeholder for my tens, so 5, carry the 1. 2 times 3 is 6, plus 1 is 7. And 3 times 7 is 21. So if I add that up, I get 275.50. Let me check that. Zeros, 5, yep. 8 and 7 is 5, yep. Carry the 1. 1 plus 1 plus 5 is 7 and 2. Right, so that is how much Peter earns. So the increase is $307.80. So this is step 1. How much Peter earns. Step 2 is I'm going to then take the information that's given in the problem of $307.80 and subtract $275.50. So in this case, it's 0, 3, 2. So $32.30 is the difference in pay for what Peter has earned. And so this is an example of a two-step problem where I have to figure out how much Peter earns to begin with by multiplying the number of hours per week. And so if you're like, well, how do you know to do that? One of the ways that I make sense of that is, right, $7.25 per 1 hour. And I know that it's 38 hours. So my hours cancel and I'm multiplying 725 times 38. So that's one of the other ways that I make sense of how to do the math. Okay. Let's take a look at problem 24. We're going to use the diagram below to answer the question that follows. So Aguilar Manufacturing Company packages a product for shipping by wrapping tape around the package as shown in the diagram. An additional 10% length of tape per package is needed for overlap. What is the total length of tape needed per package? Okay. This is a problem where taking a look at the diagram really matters. So for this box, it's important that we recognize that what is shown is only half of the box. If you think about it, right, here's my box. Right, what they've shown is one half. Here's the other half of that box. Right, so that's the half of the box that's hidden that we don't see. So whatever we're going to count up for this box, we're going to have to multiply by 2, right, because our box, right, has tape going all the way around the box. So let's think about the length of tape. So we're going to figure out the amount of tape. So I've got 5 plus 15, right? So that's this length. So 5 plus 15. I have to multiply that by 2, right? Because I have the back side that I can't see. So 5 plus 15, so that's 20. Times 2 is going to be 40. And then here, right, I've got 10 plus 5. 10 plus 5. And I also have to multiply that by 2. So that's 30 by 2, which is 60. So if I think about it, right, I'm going to add 40 plus 60, and that's 100, right, for the tape around the package. But there's an additional 10% length of tape per package needed for overlap. So in this case, 10% of 100 is really easy, right? It's just 10 because 100 is my total. So I have to add 10. So that's 110 is my total length of tape that I need. And if you wanted to go through, you could eliminate, right, just based on what we did here. So I know that it can't be A, and I know that it can't be B. And if I'm adding these together, I know that it can't be C or D, which means my only possible answer is E. So if you were trying to be speedy and shave off some time, right, you could potentially solve this problem without actually having to solve it completely. Okay. Let's take a look at number 25. So Arturo is driving at a speed of 50 miles per hour. At 2, he sees the following sign. Arturo continues at the same speed. At 2:30, how far from Canaan will he be? Okay. This problem asks us to make sense of several different pieces of information. The first piece of information that it asks us to make sense of is the fact that Arturo is traveling at 50 miles per hour. So, and it says that he stays at that speed, right? It says he continues at the same speed. So now we need to figure out, right, how far from 2 to 2:30. So from 2 to 2:30, right? That's 30 minutes or half an hour. So he travels 0.5 hours. Hours cancel. Half, or 0.5, half of 50 is 25. So he's traveled 25 miles. So if the sign said he was 62 miles away from Canaan, then we're going to take 62 and subtract 25. So that means he's 37 miles away from Canaan. So this is a great example of a problem that really has three parts. It has the part where you need to read and interpret the sign, right? It has the part where you need to think about the time. And then it has the part where you need to take the distance that is traveled and subtract it from the original information in the sign. So this is a three-step problem. Okay, let's take a look at 26. Keiko spent the day bird watching and counted 34 more birds in the morning than in the afternoon. If she counted a total of 76 birds, how many birds did she count in the afternoon? So a good way to think about this problem, right, is the missing. So 34 more birds in the morning than in the afternoon. So X is our afternoon, right? And X plus 34 is our morning. So this is afternoon. This is morning. And the total is 76. So we're going to simplify our expression. And we're going to say 2x plus 34 is equal to 76. We're going to subtract 34 from both sides. And then we have 2x is equal to 42. We're going to divide by 2. And so x is equal to 21. So the answer is A. Okay. Let's take a look at 27. We're going to solve for y. We need to get y by itself. That means we're going to have to combine like terms. So in this case, we're going to combine, right? 1y plus 3y is equal to 10. So my like terms are here. So 1 plus 3 is 4y minus 2 is equal to 10. Then I'm going to add 2 to both sides because we want to get the variable by itself. So these cancel. 4y is equal to 12. Then I'm going to divide both sides by 4. So y is equal to 3. Okay. Let's take a look at 28. We're going to read the information below and then answer the question that follows. A refrigerator in a school cafeteria is partially filled with 42 sandwiches. There are 13 turkey sandwiches, 14 cheese sandwiches, and 15 egg salad sandwiches. By the end of the lunch period, 21 of the sandwiches have been sold. Okay, so let's take a look at the information that's available here. This is what they call an inference problem. So it's asking you to make sense of what information you've been given and what you can know. So let's think about our options. It tells us that the total is 42 sandwiches. It gives us the breakdown. So there's 13 turkey, there's 14 cheese, and there's 15 egg salad. And it tells us that by the end of lunch, right, 21 have been sold. So that's the information that's available in the problem. Okay, A, can we know the number of cheese sandwiches that are sold? Well, we know the total number of cheese sandwiches, but not the number of cheese sandwiches that have been sold. So A cannot be the answer. The cost of a turkey sandwich. Well, if there's a cost, they haven't told us that, so we can't do anything with B. The total number of sandwiches that can be placed in the refrigerator. Well, we know the total number of sandwiches, but we don't actually know how much the refrigerator holds. So I don't think that C is the right answer, but we'll hold and come back to it. The total dollar sales of sandwiches during the lunch period. Nope, that one won't work either. And then E is the number of sandwiches remaining in the refrigerator after the lunch period. So the good news is it says the refrigerator is partially filled with 42 sandwiches. So because it's partially filled, we don't have enough information to know the total number that could be placed in the refrigerator. So we're going to get rid of C. That means that E is our best option, the number of sandwiches remaining in the refrigerator after the lunch period. And the reason we know that is we know that 21 have been sold. So 42 minus 21 means that there are 21 sandwiches remaining in the refrigerator after the lunch period. So we can answer that problem with the information that's available. Okay, let's take a look at number 29. Read the problem below and answer the question that follows. Wade, Jen, and Sue are going to drive cross country. To reach their destination, they plan to drive about 400 miles each day for 5 days. If gasoline costs an average of $2 per gallon, approximately how much money should they budget for gasoline on their trip? Okay, so let's think about the information that we've been given and the information that we need. So they tell us that we have 400 miles per day, and we know that they're traveling for 5 days. All right, so we know the total number of miles that they need to travel, right? They tell us the cost of gasoline, right? So they tell us that gasoline costs $2 per gallon. But we don't know the number of gallons, right? And so the way to solve this problem is to think about the miles per gallon, right? So that's the information. We need to know we know our total number of miles, but we need to know the miles per gallon that the car can travel. So let's take a look at the options. So the number of times they will have to stop for gasoline, that's not particularly helpful for us. The number of miles the car travels per gallon of gasoline, that would be really helpful for us. The number of miles Wade Jim will drive, we don't know that. There's no way we can answer that. The total distance of their trip, well, that's already given. So that's not a piece of information that's useful because we already have it. And the number of miles the car travels per hour, that's not particularly useful. It would be more useful to know the number of miles the car travels per gallon of gasoline. So we're going to say that B is the best answer because that's the information that would allow us to solve the problem. Let's take a look at number 30. Read the problem below and then answer the question that follows. So Maria left her home at 9 a.m., ran 3 miles to the lake, ran around the lake twice, and then ran home along the same route. So here's Maria's home. Maria ran 3 miles to a lake. Here's the lake. Maria ran around the lake twice and then ran back home. Okay, so what was Maria's average jogging speed? So we know that she started at 9 a.m., but we don't know what time she finished. Right? If we knew the time she finished, then we would know the total time it took her to travel the distance. And so we would be able to then figure out her average jogging speed. So speed is another word for distance divided by time. So we know, right, that she ran 3 miles to the lake, that she ran around the lake twice, and then ran home. And so we know that the total distance is 10 miles, right? If it's 3 miles to her house, right, and back, that's 6 miles. So we know that around the lake twice, right? So 4 divided by 2 means that it's 2 miles around the lake. So we know the amount, we know the distance around the lake, so we don't need that information. I think we need the time she returned home. If she stopped to rest, that might be useful, but they didn't tell us that she did, so I don't know that that's particularly helpful information. And the length of her jogging stride wouldn't be helpful to us at this point. And the amount of time it took her to run from the lake to her home, well, they don't tell us that either because they really only want her average jogging speed. So we know the total distance is 10 miles. So the only information that we are missing is her final time minus her initial time, which was 9 a.m. So if we know her final time or the time she returned home, then we can solve this problem. Okay. Great job, folks, on your outstanding work. You are over halfway there. Kudos to you. I'm going to put us in breakout sessions one more time. I'd like for you to talk through the problems and the strategies that you use for solving problems 20 through 30. Be particularly attentive to the strategies that were successful for the problems that you knew how to solve, and then work with each other to figure out what were the strategies or the challenges associated with the problems that weren't as comfortable or familiar to you. So I'm going to break us out into breakout rooms and have you work with different folks. Here you go. And I'll come in and check on you as we go. Hey
Thank
there,
you,
folks.
Sarah.
You're welcome.
Okay. Oh, I'm sorry, Clarissa. I thought I had sorted everyone. I will make sure that you get placed into a room the next round. My apologies for that. Okay. We are nearing the end, folks. Only 20 problems to go. You are almost there. So let's take a look at problem number 31. We are making great progress. You are doing amazing work. All right. Whew. Okay, so Antonio buys 4 notebooks for $3.50 each at a store. The next day he returns to the store and exchanges the notebooks for 3 notebooks that have gone on sale for $1.75 each. Antonio uses the following expression to calculate the amount of money he should receive back from the exchange. So 4 times $3.50 minus 3 times $1.75. Which of the expressions could Antonio also have used? So let's take a look at the expressions that are here. Right, so if we're thinking about our options, right, it's 4 notebooks at $3.50 each. And so he makes 1 purchase and then he returns and exchanges those notebooks for 3 that are cheaper. So the ones that have gone on sale for $1.75. So he still has 1 notebook at the cost of $3.50. And he should be getting returned or reimbursed for the difference in cost between a $3.50 notebook and a $1.75 notebook. So let's take a look at this. So if he's got four notebooks, right? So 4 times $3.50. And instead, he returns three and instead purchases 3 for $1.75. So if we're thinking about this, he's returned these guys, so he needs to get back the money for those, right? And he's already paid $3.50. So if we're looking at these in terms of options, well, we can't use A, right? That's only part of the solution because $3.50 minus $1.75, that's the difference in cost between each of these notebooks. But that's not enough to equal this expression. But this one is, right? Because we've got 3 notebooks, right? That's the number 3 here. We have the difference in cost between the notebooks. That's good. And we have the 1 notebook, right, that he wasn't able to exchange or return, right, that still cost him $3.50. So I'm going to say I think it's B, but we can check our other answers to see if there's anything else that could be a better answer. C won't work, right, because that's the opposite, right? $1.75 is just the cost of a single notebook, so that's not a good option. 4 times 3, so he didn't get 12 notebooks, so I know right away that's not an option. And 12, well, again, we can't use 12 because he didn't get 12 notebooks. 12 isn't a number that makes sense for this problem. So by process of elimination, we're able to say we know that B is the only available answer. Okay, let's take a look at problem 32. Rudy needs to calculate percent. He does so by computing it in the following way. So 50 times 14 over 100. Which of the following methods could Rudy also use to determine the correct percentage? Okay, so let's think about this. Right? What are our options? So A is definitely not an option. The reason we know it's not an option is because 100 minus 50 is not the same as the expression that we see here. Right? If we look at 50 divided by 14, that neglects the 100, so that's not an option. And if we looked at C, it's not 40 out of 50, or sorry, it's not 14 out of 50 times 100. So that's mixing up. That's not the correct expression. And D is not the correct expression because it's not 14 divided by 50. That's not an option either. But we know that 14 divided by 100 is the same thing as 0.14. So 50 times 0.14 is the correct expression. So in this case, we can go through and we can use the process of elimination to say what it's not. And then we can actually also ensure that we have the correct answer. And if we weren't certain, we could also do the math to prove that that would be correct. But in this case, we know that it's E. All right. Just a minute. Okay. Everybody hanging in there? It's a long time to be sitting. So if you need to step out and stretch, I totally understand. Grab a sip of water if you need to. Okay. 33, here we go. Use the table below to answer the question that follows. The table shows Sabra's grades for a class. For her overall average, the test average counts twice as much as the quiz average. And the final exam counts twice as much as the test average. To find her overall average, Sabra uses the following expression. Which of the following is another way to find her overall average? So a good way to think about this is, right? Her quiz average is X. Her test average is 2X. And the final exam is 2 times 2X, so 4X. Or 2 times the test average, which is the same as 4X. To find her overall average, Sabra uses the following expression. So 83, right, which is X, plus 2 times 79, plus 1, 2, 3, 4 times 88. Awesome. And then we divide that by 7, which is the overall number of assignments. Which of the following is another way to find her overall average? Okay, so let's take a look. So 83 times 2 times 79 times 4 times 88. So all of these look like they're pretty decent options. A and B do not look like good options to me. Because our average has to be divided by all terms. That's why A doesn't work. And B, right, doesn't work because those are not the right percentages. Okay, let's take a look at C, D, and E. So dividing by 0.7, right, is not correct. If we wanted to divide by 7, right, it wouldn't be 0.7. So I don't think that C is an option either. And then now we're down to between D and E. Well, in this case, we know we need to divide by 7. So multiplying by 1/7 is the same as dividing by 7. So we know that E is the correct answer. Because this term, if I'm dividing by 1/7, that's like saying this multiplied by 7. And we know that's not correct. So for 33, the correct answer would be E. Okay. Let's take a look at 34. Use the chart below to answer the question that follows. Chart above displays a relationship between values of X and Y. Given this relationship, what would be the value of Y that is missing? Okay, so this is a great example of where we need to use pattern analysis. So let's think about the pattern analysis that we can use here. So what is the difference between 1 and 1.5? Right, so if we're thinking about that in terms of structure, right, the difference between these is I'm adding 0.5, and here I'm adding 0.5. So each of these adds 0.5. What about the difference between Y? Right, so in order to go from 3 to 4.5, how do I get there? Well, in order to do that, I have to add 1.5. In order to go from 4.5 to 6, I have to add 1.5. So for each of these, right, if I'm going between 9 and 10, I'm adding 1.5. Right, going from 3 to 3.5 is 0.5. So if I'm looking here, right, what is the relationship between X and Y? Right, so if we think about this, right, given this relationship, what would be the value of Y that is missing? Well, if I needed to add 1.5, right, to 6, right, that should be 7.5. If that's my pattern. And I can check that because if I add 1.5 here, right, that's what gives me 9. So I know that I have the correct pattern. So in this case, it's really important that I'm paying attention to what is X and what is Y, because in this case, they're asking for Y for the missing term. Okay, let's take a look at 35. All right. So a school district is proposing a 5% increase in the number of days in a school year. Currently, there are 180 days in a school year. How long would the school year be with the proposed increase? Okay, so I need to figure out what 5% is. So 180, remember I have part over whole. Okay, so I want 5% out of 100. Now, it might be easier for me to figure out what 10% is. Here's my thinking. I have 180 days. If I divide 180 by 10, right, that should just be 18, right? 10 times 18 is 180. So 10, right, 10% would be 18 days. So if I think about it, if I need 5%, 5% is half of 10%. So 5% should be 9 days. Right? And so if it's 9 days, then it would be, right, how long would the school year be with the proposed increase? So then it would be 180 plus 9, or 189 days. Now note, you could also go through and solve it problem this way, right, where you multiply 5 times 180. Right, and then you divide by 100. 900 divided by 100 should be 9, right? And it gives you the same number. It just is a little bit steppier to get there in terms of your process. So it's up to you. I think it's easier to do the estimation of figuring out what 10% is and then divide by 2 to get 5%. I think that's faster for me, or more efficient. But you could also do it this way, where you cross multiply. So you have 5 times 180. You set that equal to 100 times X, and then you go through the process of solving the math. So that's up to you. Again, there are always typically more than one way to solve these problems. Okay, let's take a look at 36. Which of the following mathematical statements is correct? So we've got several options here. So, right, let's take a look. We're going to look and make sense of each of these. So is 2 2/3 greater than 3 1/3? Oh, absolutely not. So I know that A is not an option. Let's take a look at B. Well, 3 2/3 is certainly greater than 2 2/3, but it's definitely not, 2 2/3 is not greater than 3 1/3. So that's not an option. Let's take a look at C. So I have 3 1/3 is greater than 2 2/3. That's true. But 2 2/3 is not greater than 3 2/3, so that's not an option. 3 2/3 is greater than 3 1/3, so that's good. 3 1/3 is greater than 2 2/3, so D is reasonable. 3 1/3 is less than 3 2/3, but 3 2/3 is not less than 2 2/3, so my only option is D. If it's helpful, you can actually think about converting these to, instead of mixed fractions, into whole fractions, but I think it's actually pretty straightforward to do it with the mixed fractions, but that's an alternate if you wanted an alternate approach to how to solve these. All right, let's take a look at 37. So we're going to use the mathematical statement below to answer the question that follows. So we have 2/6, which is less than some unknown number, which is less than 6/8. So which of the following statements, when entered in the box, will satisfy the statement above? Okay, so let's take a look at the following. So we are trying to determine, right, which of these is going to fall between 6 and 8. So we've got a couple of ways that we can approach solving this problem. This could be a time-intensive problem that's a little bit like a trap, but let's do some thinking and figure out how we can convert to be able to do a comparison. So if I'm looking, right, I have 6 and 8, right, in terms of a common denominator. Whew. Okay, so let's see. I could do 6, I could do 24. That's kind of annoying. Can't really do 12. Okay, well, let's try it this way. We'll do 24. So 2/6. If I need to get 24, I'm going to multiply by 4, top and bottom. So 2 times 4 is 8. So I have 8 24ths. And then I have to do that for 6/8. I need 24. So I'm going to multiply by 3. That's 24, 18. So I need a number that is between 8 24ths and 18 24ths. So I can scan and look at these and see if there's one that leaps out right away that is that. And so for me, I think I can see that, right, 1/2 would be 12 24ths, and that meets the criteria of being in the middle of 8 24ths and 18 24ths. If you didn't have a number like 1/2 that you could easily recognize, you could go through and convert each of these. So I could do that process, right? I'm going to convert to 6. Right, so 6 24ths, right? That doesn't work. It's not going to be greater than 8 24ths, so I can exclude that. 1/3. So if I wanted to convert, it would be multiplying by 8. So that would be 8 24ths. I can't do B because 8 24ths, right? This is not a less than or equal to, right? Or greater than or equal to sign, right? So I can't use B. Let's take a look at 3/4. So 3/4, I'd have to multiply by 6. So 3 times 6 is 18 over 24. So I have the same problem with D that I had with B, where because I don't have a greater than or less than or equal to sign, I can't use B or D. And then 9/10. Oh, that's annoying because it's not a fraction that matches 24. But I know that 9/10 is greater than 18 24, so I know that's not an option either. So you could also solve the problem using process of elimination. Okay, let's take a look at problem 38. Which of the following mathematical expressions is equivalent to BH over 2? So if we're taking a look at 38, right, we are coming up with an equivalent expression. Well, A is not an equivalent expression because this is BH over 4. So I know A is no good. I know that B is no good because 2 times BH is 2BH. That's not an option. And I know that B over 2 plus H over 2 isn't going to become BH over 2, right? It's just going to become B plus H over 2. So that's not an option. I can get rid of C. 1/2 B times H is correct. So I can use D. And I know just for the sake of being careful that E is not correct because that would be 2BH. And we said that B was not an answer either. So both B and E are not viable answers. That means that D is the only available answer for me. Okay, let's think about number 39. Which of the following numbers is between 2,329,500 and 2,598,100? So if we're thinking about this, right, and where our numbers fall between, right, so we have 2, 3, 2, 9, 500, and we have 2, 5, 9, 8, 100. So we need a number, right, that is either between these or these. Okay, so let's take a look. 2249 is not an option, right? Because it's not between 3 and 5. So I can ignore A, that's not a viable option. 2303, right? Well, it's a 3, but it's not greater than 29. It's actually less, right? 2303, so B is not an option. What about C? C is 327, but it's still less than 329, so C is not an option. 329, 333, that's not an option either because 329 is the same, but it would have to be a number that's greater than 500. So D is not an option. That means our only available option is E, and if we check, right, it is a 5, right, and it's less than 9 because it's an 8. So we know that E is the correct option. So for a problem like this, it's almost easier, I think, if you narrow down the range that you're looking for. So in this case, I know my 2's are the same, so I don't have to pay attention to them. I'm looking for a number that's between 3 and 5 or between 2 and 9 in this position relative to in this case, 10,000 and 100,000's place. All right, let's take a look at number 40. All right, if the value of X is between 0.0051 and 0.038, which of the following could be X? So if we're thinking about this in terms of the problem, right, let's think about which is the bigger number. This is the bigger number. So 0.038. So if I think about it, right, this is the ones decimal place. This is the tens. This is the hundreds. And I'm comparing that with 0.0051, right? So again, this is the ones decimal, this is the tens, this is the hundreds, and this is the thousands. So I need a number that is between the tens decimal place of 0 and the tens decimal place of 3. So if I'm taking a look then at my options here, right, and I'm thinking about that just in terms of what do I have available, right, let's take a look. A doesn't work because A is less than 0.0051. B is a great option because B is got a 2 in the tens place, which is greater than 0, but less than 3. So I think B is a great option. But let's keep checking to make sure we're not missing anything. C won't work because 0.049 is greater than 0.038. And D won't work either for the same reason, 0.052. Both of these are too big. right? And if these are too big, then E is definitely too big. So all three of those are too big, right? B is the number that is between 0.038 and 0.0051. Okay, we're gonna go back into breakout sessions. This time I'll make sure that Clarissa doesn't get left out. Sorry about that. Sometimes when they randomly sort, we can miss folks. If you end up not getting put into a breakout room, just have a conversation in the main room with the folks that are there. But I'll go ahead and reshuffle our breakout rooms. And it should be open to you. Go ahead and join your breakout room. Introduce yourself, have a conversation with your neighbor, talk about the strategies, what worked really well for you when you were solving these problems, what might be spaces where you need some clarification or you could improve your process. Go ahead and take a moment. I'll hang and make sure that everyone has a breakout room before I head in to check in on you. And if you cannot join a breakout room, you are welcome to stay in the main room and have a conversation with the folks who are in the main room.
Hi. Did any of you get number 35?
I didn't. Actually, I'm
No.
pretty lost.
Yeah, I would think it would be like 182, but that's not an option. Maybe when she comes in, I could ask about that one. Did you get 31?
31?
Yeah.
Well, I feel like for that one, like kind of what she did, like the little squares for it, kind of helped me a little bit. Because she did kind of the 4 squares, the 4, and then she did the parentheses for the 350.
Mhm.
And then she did the 3 squares with the parentheses that was 175. But
Mhm.
one of them was already, I guess she kept one of them.
Mhm.
I don't know how to explain it.
It's okay.
She
And
kinda
I guess
crossed,
it
like,
makes sense.
It's like she crossed out like kind of like the 3 boxes. She kept that 4th one for herself, and then it was a 3 at the bottom.
All right, let me try the drawing the boxes. Thank you.
All righty, folks, you are almost there. Would you believe it? Time passes so quickly. Oh my goodness, or so long, depending upon, right? Thank you for your diligence and your focus and your attention to detail. I know that in many ways, right, these can feel tedious as we're working through and solving them, but we've only got 10 problems to go and you are almost there. We've got about a half hour left. We will solve these problems and then there will be time if you have specific questions or if there's something that is pertinent to you that we can help with. So hang in there, we're almost done. Just a little bit more and then we'll wrap up. So Abby drives 18 miles round trip between home and work each day. If her daily round trip is rounded to the nearest 5 miles, which of the following is the best estimate of the total number of miles driven in 5 days? So let's think about it this way, right? If it's 18 miles round trip, right? So if I think about a round trip, let's see, here's Abby's home. Here's Abby's work. So this is home. This is work. Right, so if it's 18 miles round trip, then it's 9 miles each way. If her daily round trip is rounded to the nearest 5 miles, I'm rounding to the nearest 5 miles, right? The nearest that I could round to would be 20, right? Which of the following is the best estimate of the total number of miles driven in 5 days? Okay, so that times 5 would be 100. So then B, right? So if we're thinking about that, right? If I'm thinking about 5 miles, right? So 0, 5, 10, and so forth, right? 18 miles, right, is closer to 20 than it is to 15. So I'm gonna round to 20 miles. That gets me closest in terms of my estimation. And then I've got 5 days. So I could also think about it this way, right? So she drives 18 miles per day, right? And I've got 5 days, right? I'm gonna replace this 18 miles with a number that I can easily multiply by. So in this case, I'm rounding to 20, 20 times 5, my days cancel, and then I'm left with miles, and that gives me the total number of miles that she traveled, which is 100. Okay, let's take a look at 42. Carrie ran the same distance in 4 different races. Her times were 18.04 seconds, 21.39 seconds, 12.99 seconds, and 14.14 seconds. The individual times were rounded to the nearest 1/10 of a second. What is the estimate of Carrie's total time for all 4 races? Okay, so let's think about this. It said, if the individual times are rounded to the nearest 1/10. So let's write out our times. We have 18.04, we have 21.39, we have 12.99, and we have 14.14. Okay, so the instructions are that we have to round to the nearest 1/10. So the 10th place is right here. So if we're thinking about that then, and we're rounding, right? 18.04, that's just going to be 18. 21.39 is going to be 21.4. 12.99 is going to be 13.0. And 14.14 is going to be 14.1. So if we add that up then, we have 66.5, right? So that is 5, 4, 3 is 7, 1 is 8, 8, 6, that makes sense. Carry the 1, and that's 6. So 66.5 seconds is what we're looking for. Okay, let's take a look at problem 43. Use the information below to answer the question that follows. The grocery store is located 3 miles away from the house. The house is located 4 miles away from the highway. Based on the information above, which of the following conclusions can be made? The grocery store is no more than 3 miles away from the highway. The grocery store is no more than 1 mile away from the highway. The grocery store is no more than 7 miles away from the highway. Or the grocery store is exactly 3 miles from the highway, or the grocery store is exactly 4 miles from the highway. So this is one of those annoying problems where if you're thinking about it, right, you have to be really attentive to the fact that we've got a grocery store that is 3 miles from the house. And we've got a house that is 4 miles from the highway. But remember, it doesn't tell us what direction. So these could point in any direction. So it's careful that I pay attention to that when I'm thinking about solving this problem. So the grocery store is no more than 3 miles away from the highway. Well, I can't say that, right? Because it could be, right? If the highway was over here, right? That would be 7 miles. So, right, I can't say A. The grocery store is no more than 1 mile away from the highway. I can't say B either, right? Because, right, if it was here, that's more than 1 mile. The only way it could be 1 mile, right, is if they were literally on the same or parallel path. The grocery store is no more than 7 miles away from the highway. Well, that one has possibilities, right? C is pretty reasonable because, right, the furthest that it could be is if it was over here, right? So if the highway was over here, the farthest that it could be is 7 miles. So I think C is a possibility, but let's keep looking. The grocery store is exactly 3 miles from the highway. Well, there's no way I can know that. And E, the grocery store is exactly 4 miles from the highway. Same problem, can't know that. So that means that I've used the process of elimination to arrive at C. And again, this is really more about drawing scenarios. So if it was helpful for you, you could draw out several different scenarios to make sense of it. So for example, here's the house. Here's the highway, this is 4 miles. Here's 3 miles to the grocery store, right? So this is the scenario where it's no more than 7 miles away because this is the furthest that the highway could be away from the grocery store. So you can always draw pictures if that helps to make sense of solving the problem. Okay, let's take a look at problem number 44. We're going to use the information below to answer the question that follows. If the distance to a destination is greater than 10 miles from home, then Matt will drive his car. If the distance to a destination is greater than 2 miles, but less than 10 miles from home, Matt will ride his bicycle. If the distance to a destination is less than 2 miles from home, then Matt will walk. So let's write those out a slightly different way and hope that that will help us make sense of the information in the problem. So if X is greater than 10, then Matt takes his car. If X is greater than 2, but less than 10, Matt rides his bike. And if the distance to the destination, right, is less than 2, then Matt will walk. Okay, so let's think about this. If Matt rode his bicycle to Zachary's apartment, which of the following statements could be true? So he rode his bike. Matt's home is less than 1 mile from Zachary's apartment. Well, I don't think we can say that. There's no way for us to know that because if it was less than 1 mile, right, he would be walking. So we know that A is not an option. Matt and Zachary live within 2 miles of each other. I don't think we can say that either, right? Because if it was 2 miles or less, he would still be walking. Zachary's apartment is about 7 miles from Matt's home. That's a possibility, right? Because 7 is between 10 and 2. So let's hold that one. That's a possibility. We'll come back to that in just a minute. All right, let's think about D though. Zachary's apartment is at least 10 miles from Matt's home. Well, if it's 10 miles, right, and it's at least, right, then he's probably driving a car, so that's not an option. The round trip distance between Matt and Zachary's is greater than 20 miles. Nope, if it was greater than 20 miles, he'd be driving a car. So that means that C is our best option for the answer that meets the criteria established by the problem. Okay. I think that one of the challenges sometimes for these problems is actually making sure that you understand how the answer is representing the information. So let's take a look at problem 45, because I'm sure they've got another one that's similar. There will be softball practice every Saturday throughout the season with the following exceptions. If it rains, softball practice will be canceled. Or there is no softball practice on the third Saturday of the month. So let's take a look. If it is Saturday, but there is no softball practice, then it must be true that it is raining. Well, that's one option, but there's another option, so we can't say A for sure. It is the third Saturday of the month. Well, same problem, right? Third Saturday of the month is one explanation, but it's not the only explanation, so B is not an option. It is raining and it is the third Saturday of the month. Well, for sure, then we know it would be canceled if that was the case. Right? What about it is raining or it is the third Saturday of the month? Well, that's possible, right? That seems like a pretty reasonable explanation. And then E, softball games are on the third Saturday of the month. Well, we know that's not true. Okay. So now, right, we're a little bit stuck, right? Let's think about C and D again and see if we can make sense. If it is Saturday, but there is no softball practice, then it must be true that it is raining or it is the third Saturday of the month. That's pretty reasonable. I think our best answer is D as an explanation. All right, let's take a look at number 46. Okay, we're going to use the table below to answer the question that follows. The partial school schedule above shows the start times and end times of class periods. Except for lunch, all classes are the same length. What is the missing start time for fifth period? Okay, so let's take a look at the problem that we're solving, right? So how long is the class schedule? So if I think about going from 8:40 to 9:36, so that's 20 minutes plus 36 minutes, so that's 56 minutes. Let's check and make sure that's the case. 20 minutes plus 30, yep, so 56 minutes, right? So if my end time is 1:15, right? What is 56 minutes from then? Okay, well, let's figure it out. So if I think about my start time, right? 56 minutes. So I need to go 56 minus 15. Right, so that's 1, 4, I got 41 minutes. So that means that my start time must be 12:19. Right, because if I think about a clock, so if 12:15 is the start, right, we're already 15 minutes in. So in order to get to the end time of 1:15, so that's my 1:15 mark. And then I work backwards, right, to get the remainder of the time for the 56 minutes. So that's one way you can solve this problem. Another way you can solve that problem is, right, you can think about the difference, right? So 1:15, right? And then work backwards from 56 minutes. Or you could think about how you could partition that in terms of segments of time that make sense to you. So I think the key here is being able to figure out that each block is 56 minutes and then being able to work backwards from 1:15. Okay. Almost there. All right, so we're going to use the chart below to answer the question that follows. Right? How many metric tons of silver were produced outside the United States in 1950? So this is where we're reading a graph. Right? So key terms here is metric tons outside the US. So this column is the US, so we can ignore that column. We're looking at outside the US, and so this is in the world. And we're looking at 1950. And we're going to read across, and it's 6323. So that's E. 6323. Right? If we think about that, right? Outside the US in 1950. So this is tricky though, right? This is a great example of a trap, right? So the whole world includes the United States. So what we need to do is take 6323 and subtract the US from that. So that's 1347. So if we subtract that, right, 6,000, right, minus 1,000 is going to be roughly 5,000. So we can do the math though to make sure. So 13 minus 7 is 6. 11 minus 4 is 7. Right, so we're at 4976. So the correct answer is A. So this is an example where we want to make sure that we're reading the table correctly. So this is the whole world. Minus the US gives us everything that is outside the US. So this is a great example where we want to read the problem carefully, right, in order to be able to answer it correctly. Okay. Let's take a look at number 48. So we're looking at US energy consumption, and it says, according to the graph below, what was the maximum difference in energy consumption between the two sources of energy in any one of the years shown? So here I'm looking for the maximum difference. So the maximum difference is the greatest spread. So it looks like it's the difference here or the difference here. So if I think about it in terms of here, so this is 6 minus 3. This is 2.5 minus a little bit above, so maybe 2.5 minus 2.25. So if we have that difference, then the greatest difference between these two, let's take a look. What do we think in terms of 48? So this is a little bit above, so maybe 6.2. Hard to read from the scale. That's just an inference. So it looks like 6.2 minus 3 would be 3.2. That seems to be the greatest separation or spread. So 2.5 minus 0.25, that's still 2 and some change. So that would be C, that's still less. And we don't have anything bigger than E, so we can ignore that. A is too small a difference. I think D is the best answer based on the information that we have available. Okay. Let's take a look at 49. All right, so we're going to use the chart below to answer the question that follows. We have the percent of total corn crop yield in 1999. What percent of the total crop yield did the central farm generate? Okay, so we've got all of our percentages. So we've got 24 plus 21 plus 7 plus 31. And we don't know what C is. So C is our central farm. And if those add up, they should add together to equal 100. So if we add, excuse me, if we add everything up, let's see what we've got. So we've got 24 and 21. So that's going to be 45. 45 and 7. 52. 52 and 31 is 83. So we've got 83 is the percent total of all farms other than Central Farm. So 100 minus 83 gives us 17. Okay, so 17% for A is the correct answer. And if we weren't sure, we could get rid of B, right? Because that's one of the values that's already given, and that's, right? It's too big for, right? It would be over 100%. Same thing for C, same thing for D, same thing for E. So all of these values are too great. They would give us a percent that's greater than 100. So we know they can't be the correct answer. Okay. All right. Problem number 50. Use the graph below to answer the question that follows. The graph shows the sales of a commodity over a 60-year period. Between what years did sales increase by the greatest amount? Between 1940 and 1950? Between 1950 and 1960? Between 1960 and 1970? Between 1970 and 1980? Between 1980 and 1990. So we're looking for the sales increase. So we want a change in the slope that is steepest. So I think the change in slope that is steepest is here, because that's where we see the greatest increase. Right here, it's relatively small. Here, it's relatively small. Here, it's very small. This is probably our greatest increase. So if I look, right, this is between 1950 and 1960. So that's B. Okay. So this is a great opportunity for you to go back. I'm going to send you out into breakout rooms one more time. Check with your teammates or your peers. See if there were strategies that you had that were really successful for solving certain problems. If there are problems that you were struggling with, see if your peers, colleagues, future teachers had solutions or strategies that were more successful for you. So let's go ahead and break out into breakout rooms. Make sure that you have a conversation with your peers, and then we'll come back together and wrap up. Wonder why. It's so interesting. Huh. So Blaze, Gabriella, and Akobos, for some reason, it doesn't sort you all out into breakout rooms. I'm not sure if I know why that is. But if you guys don't mind in the main room having a conversation with each other, that would be great. And if you have any questions, I'm happy to answer any clarifying questions that you might have. And if you just need a minute to think, that's totally fine by me.
Did anybody have any trouble with any specifically? These ones seemed okay for me.
Same. These ones are a little easier.
I like ones with visuals, always helps.
Mm-hmm.
Yeah, there's nothing I really had any questions on. Except for 45, and I just kind of answered it before I read all the answers, and I put C initially, but they're those two both.
I did that for a couple. Like I didn't read it all the way through. I kind of assumed what they were looking for versus reading the answer completely or the question completely.
I think that's going to be my biggest problem on the exam.
Yep. Just gotta slow down and reread it. Are you gonna take it soon?
Well, I was registered to take it, before all this happened, and they canceled it, and I got rescheduled for November. But I saw that they're doing it other places. I'm gonna try to take it somewhere else.
Mm-hmm. Yeah.
What about you?
No, not yet. This is kind of my practice before I haven't graduated yet.
Okay.
And the program I'm looking at for my credential is next summer. So I figured I had a little time to try to get as much practice in beforehand.
That's it. I'm like fresh out of like the, Math 309 and stuff. So I just want to take it like right away.
There you go. That's a good idea. It's been a while since I've taken math, so that probably would have been a better idea.
Oh, I know. It's definitely, yeah, I think I'm ready for it.
Yeah. Nice.
I think you're muted, Corinne. Oh, yeah.
I forget that when I come back in the room, it mutes me. My apologies. Okay, kudos to you. Congratulations. You made it through 50 problems, which is no small feat. I think it's really important and valuable for you to see, though, right, that we did all 50 problems. And if you think about the pacing of the problems that we did in terms of timing, that should give you a good estimate of how long it takes you to think about solving problems. So when you're planning your time for taking the CBEST, pacing is definitely something that you want to take into consideration. I often have folks ask, so what's the next step? What should I do? I think that this is a great opportunity for you to go through and think about what questions you felt really confident with, and then what were questions that, oh, if you could just ask that would never show up on the CBEST, you would be so happy. So those are the problems then that you want to go back and review or revisit. So I think from a strategy standpoint, that's going to be really helpful. In your, in your folder, there are some additional resources that I wanted to share with you. So let me stop sharing my overhead and share something else instead. So in the folder that Margaret shared with you, there are actually some additional review resources. So if you want some additional help reviewing topics, there are practice problems for you to work through. So if there were specific subsets of these problems, you're like, oh, you know what, I really need some additional practice with graphing or with geometry, then these are resources that are available to you. They're found in the folder that she shared. So the CBEST preparation, there's math.
Actually, Corinne, I didn't share the folder with them. I just sent the booklet. So I'll go ahead and share it at the end of this workshop today.
Cool. I can also send it out by email too, if that's easier, whatever would work best.
That's perfect. Thank you.
Of course. And so there's also several other free resources. So there are a number of resources that you can pay to have additional support. But this one I actually thought, actually go here for a minute. So this is the math help. I really like the structure of this setup. So they have short videos, right? And then they have a bunch of different types of practice problems. So if that's something that's helpful, that's a really great resource that's available to show you an example of what these look like. So these are additional resources where it's similar, right? So it's practice problems, but then what I really liked about these is it actually at the bottom gives both an answer and an explanation. So sometimes you can have practice, but they don't give an explanation, and then that's not as helpful if you're trying to figure out what you didn't do correctly. So I found that these resources were really helpful. If you have specific questions, you're like, oh, I really need help with this type of problem, you are welcome to email me. So my contact information, I'll put this here. I'll make it larger so it's readable. But if you shoot me an email, I'm more than happy to help by email as well. And I know that we're essentially doing distance learning, but it's really easy to set up a Zoom session. So if as you're doing CBEST prep, but you're like, hey, I just want some extra math help, or I need clarification on this problem, it didn't make sense to me, it's really easy to set up a 10 or 15-minute Zoom session if going through a specific type of problem would be helpful for you. So please know that resources are available. We're happy to help. I'm delighted by the work that you've done here, and I'm so glad that you are making the investment in our future students and workforce. I can't thank you enough for all that you do. So if there are questions I can answer for you, I'll happily do those now. Otherwise, I don't know if there's any information, Margaret, that they need to know from you.
No, nothing from me. After this, I'll share the drive and the recording of this workshop.
Awesome. So I will happily stay and hang out and answer any questions that you might have. But otherwise, thank you so much for your time, energy, and attention. We are thankful for you.
Thank you,
Thank
Corinne.
you.
Thank you, Margaret.
Thank you.
Thank you.
Thanks, Margaret.
Everybody.
Thanks again. Have a great day, folks.
Thank you.
Thank you so much.
Bye.
Thank you.
I
Good
just
luck,
had one
everyone.
question.
Of course.
So I did see where you guys had put in our
the practice
Huh?
for us, there was also another attachment with the answers on it.
Yep.
This one.
Mhm.
So is that just a different set of questions and you guys gave us the answer so we can maybe figure it out and work on those?
That's correct. So
Okay.
the step we went through today is one 50 problem CBEST example. The other one that's there is another practice test for you to take.
Okay,
So
great.
one of the things that I recommend is like we were really structured and intentional and purposeful in terms of the timing and
Mhm.
working through these problems. I think it can be really helpful if you set a timer for yourself and figure out your own kind of pacing as you work through different sections. And so that's what the that exam is for as well.
Okay, thank you.
You're most welcome.
I
Thanks.
have one question.
Of course.
I was wondering, how long does it take the actual CBEST format?
Ooh,
1 hour?
so that's a good question. I think their turnaround time is 2 weeks, maybe 4 weeks in terms of getting scores back to you. And I think in terms of the actual format of the test itself, this is where you have a little bit of choice because you have 4 hours total and it depends on what you sign up for. So for example, if you wanted all 4 hours to do math, then you could just sign up for the math subsection. Or if you were like, no, I don't actually think I need all 4 hours, I'm going to do all 3 of the subsections in 4 hours, then you could sign up for all 3. So some of it is up to you and the pace that is the best pace for you in terms of taking the test. Does that make sense? So the
Yes.
bummer is that every time you sign up, you still have to pay, I think, in order to be able to take the test. But I believe that there are also some scholarships that are available. So I think that might be something worth checking in with Margaret about in terms of taking the CBEST.
Okay, thank you.
Of course.
Okay, have a nice weekend. Bye.
Oh, you as well. Thank you, Maria. Great question.
Thank you.
I have
Any
a
other
question.
questions?
Yeah.
Yeah, Sarah.
So I have a practice